Let's continue on doing more partial fraction integrals. We have 2x cubed minus 12x squared minus 79x plus 39 over x squared minus 6x minus 40. So let's take a look at our checklist. Use long division as needed. Well, I see that the degree on top is actually 1 greater than the degree on bottom. So if it's greater than or equal to, we have to do long division. So instead of getting started normally, like we have in our previous examples, we've got to do some long division first. So let's set this up. X squared minus 6x minus 40 to So if you haven't checked out the video we did on long division here, I recommend you do that because this might be a little foreign to you. So what we have to do is we have to match this and say, okay, this goes into this, looks like 2x times. So then I'm going to get 2x cubed multiplied by this, negative 12x squared minus 80x. And then when I subtract, this disappears, this becomes a positive x plus 39. So what that tells me is that the polynomial that we started with is actually so this 2x cubed minus 12x squared minus 79x plus 39 all over x squared minus 6x minus 40 is actually 2x plus x plus 39 over x squared minus 6x minus 40. So what does that do for us? Well, that tells me that this is actually the fraction that we're going to do the decomposition on. No longer do we care about this. We have, this will still be used in the integral, but this is what we're going to decompose. So now we can move into step 2, which is to factor the denominator. So if we factor this denominator, x squared minus 6x minus 40, we get x minus 10, x plus 4. So that's kind of our standard x minus 10, x plus 4. So then we have to separate the linear factors, separate the quadratic factors, and then we'll solve. So we're moving on to step 3. Step 3, we say x plus 39 is equal to a over x minus 10 plus b or x plus 4. Now, for step 4, we don't have any quadratic factors, thank goodness, so we can continue on. The next step is just to solve. So we're going to, if we multiply the denominator on both sides, and that denominator is this, x minus 10, x plus 4, it will cancel the denominator completely here, giving us x plus 39. And then over here, if we multiply this on both sides, the x minus 10s will cancel, so I'll have a, x plus 4. But when I multiply it by this piece, the x plus 4s will cancel, so I'll have b times x minus 10. So now what's left is to choose those convenient values. Alright, so since we have linear factors, we can pretty much just choose the values of values that will cancel each of these terms. So if I pick x to be 10, then when I plug in, I get 49 equals a 14, and then the b term vanishes. So what that gets me here is that a is 7/2. Now if I pick x is negative 4, I get 35. This vanishes, this becomes negative 14. So b is negative 5/2. So b is negative 5/2. So now that we have those pieces here, we can put them together. We have what a and b are, so we can rewrite this. I guess we'll take it from here. So we will rewrite that integral. So that this whole thing here is equal to 2x. So you can't forget this piece. We didn't just divide it for nothing, by the way. You have to remember that piece. Plus the decomposition here, which is 7/2 over x minus 10 plus negative 5/2 x plus 4 dx. So now that we have that, we can simply do antiderivation. So the antiderivative of 2x is going to be x squared. So this is just some number over x minus 10, and that's just that shift, right? So you could use u equals x minus 10 to do a u sub. So you have some constant natural log of x minus 10. You could use a u sub here of x plus 4 minus 5/2 natural log x plus 4 plus c. And that's going to kind of set you up there. So the key here was that the long division generates you this term, which you still have to take the antiderivative of. But it does make the remaining fraction a lot easier to deal with than if you had just had this 2x that you were dealing with.